Hey everyone. So today we're in the pre-algebra class on Khan Academy. I'm going all the way down to the bottom to the Unit 15 test on systems of equations. Just scroll down, and today we're going to take the unit test. All right, this one has a graph that looks fun. It wants us to graph the solution. I am going to do that. I'm pretty sure for these examples, you can actually just put in the solutions here. You could solve algebraically, but let's solve it graphically. Okay, so first, I'm going to look at my first equation here, y equals negative 5x plus 6. So this is in slope-intercept form. So I have a y-intercept of 6, so I'm going to put that on my graph. A y-intercept, so on the y-axis, I'm intercepting it at positive 6, and then my slope is negative 5. So from my intercepts, I can go down 5, 1, 2, 3, 4, 5, and then over to the right 1. Why does this work for the slope? My slope needs to be negative 5 over 1. And this is my rise over run. You can think of it, or change in y, my change in y over my change in x. So if my y is going down 5, I need my x to go to the right, positive 1. So that'll give me negative 5, because down is negative, and then over positive 1, because to the right is positive. All right, so I like that one. Next one, let's circle it in red. We have 3x minus 2. So y-intercept is negative 2. So I'm going to take my other line, and I'm going to put the y-intercept. So I'm going to intercept the y-axis at negative 2. And then my slope is 3. So I'm going to go up 3 from there, up 1, 2, 3, and then over to the right, 1. Again, this is giving me a slope of 3 over 1. Slope of 3 over 1. Let's draw it. Slope of 3 over 1. So if I go up 3, that's positive 3. I then need to go to the right 1. Positive 1. 3 over 1. So it's up 1, 2, 3 to the right 1. So it looks our solution is here. The x value is 1, and the y value is also 1. So the solution is 1, 1. X is 1, y is 1. So that's what I'm going to put in my answer box. All right, very nice. All right, this one says solve the system of equations. So it doesn't give us a graph. If you wanted to do this graphically, you could. You could just put it in slope-intercept form and graph it, but I'm going to do it algebraically. So for this one, I see that the second equation, it's already solved for y. So the second equation says y equals x plus 4. So if I know that y equals x plus 4, I can use x plus 4 and substitute it in for y, since they are the same thing. This will let me solve for the variable x. So what I'm doing is I'm taking y in the second equation because I know y is the same exact thing as x plus 4. So what I can do in the other equation is instead of y, I'll put in x plus 4. So let's do that. So I get 12x minus 5. And I'm not going to use y. I'm going to use x plus 4. They're the same thing. I'm substituting in x plus 4 for y. This is going to allow me to solve, because now you'll see I have only x, so I can actually solve for x. So let's do that. So I have 12x minus 5x. I'm going to distribute the negative 5. Minus 5x minus 20 equals negative 20. Let's add 20 to both sides. Oh, these are x's. X. So I'm going to get 12x minus 5x is 7x. If I add 20 to both sides, I'm getting 0. So I'm thinking that x is 0. I can divide both sides by 7, but I'm going to get x is 0. So for the moment, I'm going to believe that x is 0. What would that mean y is? So let's use this equation. If x is 0, y must equal 0 plus 4. So if x is 0, then y is 4. I'm going to check that, though. So what I would do is, like, I think it's right. I'm going to check it in this equation here. So if I can plug in 0 for x and 4 for y, and this equation works out, I'm very confident this is the right answer. So 12 times x is 12 times 0, which is 0. And then minus 5 times y, if y is 4, does that equal negative 20? On the left side, I have negative 5 times 4, so I have negative 20 equals negative 20. I like that. All right, so things are looking good. So I think x is going to be 0 and y is going to be 4. Very nice. All right, so take a look at this one. So this one asks directly, is 3, 4 a solution? So I don't need to solve. I can just check. So here the x value is 3. So let's say I check this first one, and the y value is 4. So what I'm going to do is replace y with 4, and I'm going to replace x with 3. So -8 times, instead of x, 3, minus 3. I'm just going to check that this works out. So I get 4 equals -8 times 3 is -24 minus 3. So I'm thinking this is not going to work out. I'm getting 4 equals -27. That is not true. So it looks like this solution 3, 4, it does not work for the first one. So that means it doesn't work for the system. So it's not, this one's not going to work. You only need to check one. If it doesn't work, then the answer is no. If it does work, you got to check the other. All right, solve the system of equations. Sounds like fun. So this one sets us up really well for substitution because it says that x equals -3y plus 8. So what I'll do in my first equation is instead of using the variable x, I will use -3y plus 8. Then I have -6y equals 4. So let's switch colors. So what I'm going to do is solve for y now. I have only y. I can solve for y. I'm going to distribute the -7. -7 times -3y is positive 21y. -7 times positive 8, -56. I hope that's right. Is that 7 times 8? Hopefully. Minus 6y equals 4. All right. So simplifying, combining like terms, I have 21y minus 6y, so that's 15y. And I am going to add 56 to both sides. And this gives me numbers that are pretty clean because on the right side I now have 60. If 15y is 60, then y is 4. I can divide both sides by 15. 15 times 4 is 60, so y is 4. So we're going to roll with y is 4. I'm going to plug it into this equation here. Oopsies. And solve for x. So if y is 4, then x is -3 times 4 plus 8. So x is -12 plus 8 is -4. So I think that x is -4 and y is +4. But I will check that. So let's check it into the other equation, this one here. So I'm going to do -7 times x. X is -4. Minus 6 times y. Y is +4. And that should equal 4. Hopefully. -7 times -4 is positive, and that's going to give us 28. So 28 minus 24, 6 times 4 is 24. That does equal 4. So I like it. So I think that's a good answer. X as -4, y as +4. All right, next one. Is 3, 8 a solution? Let's check it. X is 3, y is 8. Let's check the first one. So 8 is the y value. Does that equal -5 times 3 plus 1? That doesn't sound right. 8 equals -15 plus 1. That's -14. Don't like it. Check the first. Doesn't work. I'm going to give it a no. Very nice. All right, let's solve. Let's do this one graphically. I think, actually, I'm not going to do this one graphically. You don't have to do the graphs on these. It says you can use the interactive graph. I'm not going to do that. I'm going to do this algebraically because it's set up so well for elimination. So here, what I'm going to do is I have these equations stacked. I'm going to go ahead and use elimination method. So I'm going to add these together. If I add these, 8x plus 8x is 16x. -4y plus 4y cancels. That's why I like this. This is what is being eliminated in the elimination method. The y's go away. 16 plus 16 is 32. Through the elimination method, I'm getting x by itself. X equals 2 because I can divide both sides by 16. And if x is 2, I can now solve for y. So what I'll do is maybe I'll use the bottom one. So I'll say 8x, that's 8 times 2 plus 4y equals 16. This is coming out a little funny. So 16 plus 4y equals 16. So if this is true, think about this. What does y have to be? Y has to be 0 because 16 plus nothing is 16. So in this case, y would have to equal 0. I will check that. So let's check it in this bottom equation, or sorry, the top equation. Let's check the top equation. And let's check if 2, 0 works. So if x is 2, that's 8 times 2, and it is going to work, minus 4 times 0 equals 16. And that's correct. 8 times 2 minus 4 times 0 is 16, because it's 16 minus 0. 16 equals 16. So I get a good solution there. X is 2, and y is 0. All right, is 2, 3 a solution? So it's positing that x could be 2 and y could be 3 as a pair. Let's check that. So 2x would be 2 times 2 minus 3y, that would be minus 3 times 3. So that's 4 minus 9. We better get negative 5. And that's what the equation says. So 4 minus 9 equals negative 5. That's right. So now I'll check it for the other. So this one says 4x, so that's 4 times 2 minus 4 times 3. So what should that be? Is it going to be negative 4? So it's going to be 8 minus 12. And yes, that is negative 4. So my numbers 2 and 3, 2 for x, 3 for y, they work for both of these. So yes, it is a solution to the system. All right. Solve the system. So this one here, I have the second equation, y is already solved for. So I have y equals 3x plus 15. So what I'm going to do is in the first equation, I'm going to replace y with 3x minus 15. So in the top, I get negative 4x plus 7 times y, but y is equivalent to 3x plus 15. This should equal 20. So solving for this now, I get negative 4x, distribute the plus 7. So 7 times 3x is 21x. 7 times 15, that's 70 plus 35, 105, equals 20. Hopefully this is going to give us some nice clean numbers here. Negative 4x plus 21x, that is 17x. Yikes, 17x. I'll subtract 105 minus 105. So 17x is negative, is it 85? Yeah. My hope is that this divides out pretty well. So let's do 85 divided by 17, and we will pray. Thank goodness. So it's going to be negative 5, because the negative 85 divided by positive 17 is going to be negative 5. So x here is negative 5, at least if our math is right. X equals negative 5. Let's plug in negative 5 for x. I'll just do it here. So that means that y equals 3 times negative 5 is negative 15 plus 15. So we got another 0. So y should equal 0. Let's check that. Let's check it here. So let's make sure this all works out with the x and y we have solved for. So negative 4 times x, but x is negative 5. And the 7y, it should be 0. That makes sense, because this is 20. But plus 7y, y is 0. Does that equal 20? I believe it does, because negative 4 times negative 5 is positive 20. And this is plus 0. So just 20 equals 20. So that is correct. All right, so x is negative 5, y is 0. Fun, fun, fun. Last one. Oh my goodness. So it says estimate the solution to the system of equations. You can use the interactive graph below to find the solution. I think I might actually do that. So what I think I'm going to do is I'm going to write these in slope intercepts. and I'm going to graph it. So let's do that. Yeah, so let's write over here. So I have 7x minus y equals 7. I want to get a slope intercept. Maybe I'll add y to both sides. So 7x equals y plus 7. Now I can subtract 7 from both sides. I'm getting y by itself, and that's going to equal 7x minus 7. So one of our equations, equation 1, is y equals 7x minus 7 in slope-intercept form. Equation 2, this one here, the 2y, I'll subtract x from both sides, negative x plus 6, divide by 2, divide everything by 2. So y equals negative 1 divided by 2 is negative a half. 6 divided by 2 is 3. So this is equation 2, and it has a slope of negative 1/2 and an intercept of 3. So what I'm going to do now is I'm going to graph these on the graph, and that is going to allow me to estimate the solution. So if I do the first line, the blue line, the intercept is negative 7, way down here, and the slope is 7. So I'm going to go up 7 and over 1. So from the intercept, up 7 over 1. So I like that graph. And then the green one has an intercept of 3. So an intercept of 3 and a slope of negative 1 over 2. So negative 1 over 2. So this one looks something like this. So the solution is somewhere in the vicinity. The x value is like 1 1/3. So it's like 1 1/3. The y value is 2. Ish. Oh, no. This is the solution. So x is like 1 1/3, but y is like 2 1/3. So x is 1 1/3 because 1 and a little bit, and y is 1 2 1/3. So 1 1/3, 2 1/3. I'm going to look for the answer that matches that most closely. And it's looking like answer B. X is 1 1/3, y is 2 1/3. That's the only one of these that kind of gives you that right solution. All right. So I hope this helped out. Have some fun.